So today we are going to start a new topic that is called the power of the lens. Okay, so it is written here. You can see the power of the lens. What is the meaning of the power? Power of the lens. The power of the lens means it is measured of its ability to converge or diverge the parallel beam of light on refraction through it. That means what? That means suppose this is a convex lens. This is the principal axis, and this is focus. This is also focus. F1, F2. Then this one is 2F1, and this one is 2F2. Now this lens will bend this parallel beam of light to up to this. Okay, so this is his focal point. Now if there are another lens is there, suppose this type of lens, so which can bend more earlier rather than this, which can bend the parallel beam of light more earlier in this way. Okay, so that means the power of this lens will be more. Okay, so I'll give you comparisons on two drawings, you can understand easily. So suppose this is a normal lens, and this one is the principal axis. Parallel beam of light is going here, and it is bending here. So see from these two pictures, on which cases the light is bending more earlier. So in this case, light is taking too much time to bend. So it is traveling so much distance. Okay. So here is principal axis is here. That is the focal point. So that is why the power of this lens is less than the power of this lens. So the ability of the bending of parallel light. So if the lens were not there, the light will pass through like this. It will go straight line. When you place the lens, the light will bend in this way. The ability of bending the lights, or this is in case of convex lens. And in case of concave lens, the ability of diverging the light. So like this lens, so the parallel beam of light will come and then it will diverge in this way. Okay, so more it will diverge, the power will be more. Okay, so that is the thing. So definition will be the power of the lens is the measure of its ability to converge or diverge the parallel beam of light on refraction through it. That is called the power of the lens. Okay, so now from here also you can understand the power of the lens is defined as a reciprocal of the focal length f expressed in meter. So what I said, in this case the power is less. Why? Because f is more, power is less, and in this case f is less, the power is more. So we can write a mathematical expression, P is called the power of the lens, will be is equal to 1 by f. F is in meter. So now if we convert into centimeter, then what we get? We get centimeter means, so then it will become 100 by f. So in centimeter. So normally we measure the focal length with the centimeter, so that time you have to use this formula. Okay. So now sometimes the question comes that why the power of the lens expressed as the reciprocal of its focal length. So your answer will be that power of the lens represented by the ability to converge or to diverge the beam of lights, as smaller its focal length or larger its bending power. Okay, and this is why the power is expressed as the reciprocal of the focal length. Okay, so you can write this one. So smaller its focal length, write it, smaller its focal length, just a point, note it down, smaller its focal length, larger is its bending power. Okay, so that is why the power is expressed as the reciprocal of focal length. So power of length is expressed as the reciprocal of focal length. Okay, so now what will be the SI unit of the power? So if F is taken SI unit, so now if F is 1 meter, F is equal to 1 meter, so you can write P is equal to, so power of the lens P is equal to 1 by 1, that means 1 to the power, so 1 into n to the power minus 1. So this is also called the diopter. 1 diopter, DIOP TRE, diopter, or in short form you can write D. Okay, so this is called the diopter of the lens. Remember this one, so that will be in meter. Okay, so it's SI unit. So already we discussed in the first this unit and measurements, you know this one, we studied in class 9, that SI unit of length is meter. Okay, now here is one sign convention. Okay, so power sign convention, we write down sign convention. Okay, the power of converging lens is positive. Power of converging lens means what? Means convex lens. Power of converging lens is positive. Okay, so that is because F is positive, because F is positive. And next one is power of diverging lens is negative. That means in this case it is negative. Where is the focus? Focus is here in this point. So power of diverging lens is negative, as or because F is negative. Okay, so now we learn that the instrument, the name of the instrument which is used by the opticians to measure the power of the lens. So to measure the instrument used to measure the power of the lens, right? The instrument used to measure the power of the lens is called diopter meter. DIOPTREMETER, diopter meter. Okay, so now then you can ask question that what will be the power of the glass plate. So in the case of power, the glass plate, suppose if I think the glass plate will look like this, there is some thickness will be there like this way. Okay, so this is a glass plate. Now in this case, see, there is no carving at all. Okay, there is no carving, no curvature. So the power of the glass plate will be 0 because the focal length is infinity. So you can write also the power of a glass plate is 0 as focal length is infinity, as its focal length is infinity. Okay, so now we'll go to the next page. Set up first. Wait. Next one is the power of the lens combination. Suppose several lenses are kept close together, then what will be the power? So you can write down if the number of lenses of power, suppose P1, then P2, and then P3 are placed in contact with each other. Okay, then the net power of the combination, so like this way. So one lens is kept here, another is kept here, like this way. If they are kept in this way, then what will be the combination with the net power? So normally it is the algebraic sum. Okay, so combination is equal to the algebraic sum of their individual power. So you write down the net power P of the combination is equal to the algebraic sum of their individual power. So you can write individual powers. So you can write P is equal to P1 plus P2 plus P3 and so on. If in case if some in this way if some concave lens appear, then what will happen? It will be minus. Okay, because the power of the convex lens is minus.